Lesson: Fundamentals of Predictive Analytics. Predictive analytics serves as a cornerstone in the realm of data science and artificial intelligence, offering the ability to predict future outcomes based on historical data. This capability is crucial for making informed decisions and fostering strategic advantages across various sectors, including finance, healthcare, marketing, and more. At the heart of predictive analytics lies the methodology of utilizing statistical algorithms and machine learning techniques to identify the likelihood of future outcomes based on historical data. The primary goal is to go beyond understanding what has happened to providing a best assessment of what will happen in the future. To effectively implement predictive analytics, professionals must first understand the essential components that drive these predictions. The process begins with data collection and preparation, where raw data is transformed into a suitable format for analysis. This involves cleaning the data to handle missing values, outliers, and inconsistencies, which is often the most time-consuming part of the process. Tools like Python's Pandas and R's Tidyverse are frequently employed for data manipulation and cleaning. These tools enable analysts to streamline the data preparation process, ensuring that the datasets used in predictive modeling are as accurate and representative as possible. Once the data is prepared, the next step involves selecting an appropriate predictive model. This choice depends heavily on the nature of the problem and the type of data available. Commonly used models include linear regression, logistic regression, decision trees, and more advanced techniques like random forests and neural networks. For instance, logistic regression is often utilized for binary classification problems, such as predicting whether a customer will churn or not. On the other hand, decision trees are advantageous for their interpretability and can handle both categorical and numerical data. The model selection process is closely followed by training and validation. During training, the model learns patterns from the historical data, while validation involves testing the model's performance on unseen data to ensure its predictive capability. Cross-validation is a robust technique employed during this phase to prevent overfitting, which occurs when a model learns the training data too well and fails to generalize to new data. Practical tools such as scikit-learn and Python provide a comprehensive suite for model training and evaluation, facilitating processes like cross-validation, hyperparameter tuning, and model comparison. Once a predictive model is validated, it is deployed to generate predictions on new datasets. However, for predictions to be actionable, they must be interpreted correctly and communicated effectively to stakeholders. This often involves translating technical model outputs into business insights that can inform decision-making processes. Visualization tools like Tableau and Power BI play a critical role here, enabling analysts to create interactive dashboards that convey complex data insights in an accessible format. These tools help bridge the gap between data scientists and business leaders, ensuring that predictive analytics can drive tangible outcomes. A practical example of predictive analytics in action can be seen in the retail industry, where companies leverage customer data to predict purchasing behavior. By analyzing past purchase histories, demographic information, and browsing patterns, retailers can forecast future purchases and tailor marketing strategies accordingly. For instance, a company might use predictive analytics to identify customers who are likely to buy a particular product and target them with personalized promotions. This approach not only increases sales, but also enhances customer satisfaction by providing relevant offers. In healthcare, predictive analytics is used to anticipate patient outcomes and optimize treatment plans. By analyzing patient records, genetic data, and other health indicators, healthcare providers can predict the likelihood of disease progression and intervene proactively. For example, predictive models can identify patients at high risk of complications after surgery, enabling clinicians to apply preventive measures and improve patient outcomes. A study published in the Journal of Medical Internet Research highlighted the effectiveness of predictive analytics in reducing hospital readmissions, demonstrating its potential to enhance patient care and reduce costs. Despite its advantages, predictive analytics is not without challenges. One major concern is the quality and quantity of data available for analysis. Inadequate data can lead to biased models that produce inaccurate predictions. Additionally, ethical considerations surrounding data privacy and the potential for algorithmic bias must be addressed to ensure responsible use of predictive analytics. Professionals must adhere to best practices in data governance and remain vigilant against biases that may arise from unrepresentative datasets. To address these challenges, practitioners should adopt a comprehensive framework for predictive analytics that encompasses data governance, model development, validation, deployment, and monitoring. This framework should emphasize transparency, accountability, and continuous improvement to ensure that predictive models remain accurate and relevant over time. Furthermore, organizations should foster a culture of data literacy, encouraging all stakeholders to understand the principles and limitations of predictive analytics and engage in informed discussions about its applications. In conclusion, the fundamentals of predictive analytics involve a systematic approach to data-driven decision-making that can significantly enhance organizational performance across various industries. By leveraging practical tools and frameworks, professionals can develop effective predictive models that generate actionable insights and drive strategic initiatives. As the field continues to evolve, staying abreast of emerging techniques and technologies will be crucial for maintaining a competitive edge and unlocking the full potential of predictive analytics.